sixth grade science review sheet. So it's double-sided. On one side you have this paper with weather and clouds and atmosphere. On the other side you have space, solar system stuff, and the water cycle. Alright, so this is hopefully everything we talked about in elementary school, but if not, definitely go over this because this is some stuff you might want to see, you might see on the SOL. So the Earth's atmosphere, the atmosphere is all the air around us, okay? So the Earth's atmosphere has different gases in it. The most common or abundant gas that takes up about 78% is actually nitrogen. I know it's weird. We breathe in all this oxygen, but nitrogen is actually the gas that is most common or abundant in our atmosphere or in our air. About 22% of the atmosphere in our Earth is made up of oxygen. Alright, and 1% is basically a lot of other gases, like noble gases like argon and CO2. But if they ask you on the SOL, like which gas is the most common in our atmosphere, you need to know it's nitrogen, not oxygen. Okay. Where's most fresh water on Earth? Okay. Is it in glaciers and ice caps? Is it in groundwater? Glacier and ice caps, sorry, there was a person at my door. Groundwater or lake and streams. So obviously most of it is this dark one. So most fresh water on Earth is in glaciers and ice caps. Okay, fresh water is no salt. It's just fresh water, no salt in it. Okay. All right. The atmosphere, so the air around us, has 5 layers. Okay, the layer we live on, or the first layer on the bottom, is called troposphere. Okay, in the troposphere, this is where weather occurs. Okay, and this is where we live. Above the troposphere, we have stratosphere. The stratosphere has the ozone layer, which protects us from the sun, and planes fly on the bottom of the stratosphere. Okay, if you want, you can draw a little picture of a plane. Don't judge my picture. And then over here. So planes like to fly here because it's right above the weather. It's right above the troposphere. You don't want to fly a plane into the troposphere because that's where weather happens. So that's where the atmosphere is not really stable. Okay. Above the stratosphere, we have the mesosphere. Mesosphere. Okay. Meso means middle. So this is the one in the middle. The mesosphere is important because it helps us stop meteors, those big giant rocks from space. So when a meteor goes through our atmosphere, it'll dissolve or disintegrate in the mesosphere. It won't crash and hit us and make us go extinct. Above the mesosphere is the thermosphere. Okay? This is important because it absorbs the harmful UV rays from the sun. Okay? Above the thermosphere, we have the last layer, which is exosphere. Okay? Exo is an important word in science. Exo means outer or outside. Okay? Like an exoskeleton, the skeleton on the outside. Okay, so exosphere, this is basically like when outer space starts. So these are where we have our satellites. Alright. Alright, so now we have a weather map. You kind of need to know weather maps and symbols. So H, is an area of high pressure. C is an area of low pressure, or not, L, excuse me. Okay, a cold front looks like icicles that are frozen. Okay, so like little triangles. Okay, so just think icicles. Icicles. I think that's how you spell it. Actually, I don't think that's how you spell it. I think it's like maybe like this. Icicles. Alright. A cold front brings a cold air mass. Cold weather. A warm front. Warm fronts look like little suns. It's warm. Okay, so I'm sure you've seen these little symbols on like the Weather Channel. Okay, so the one with like a line, a curvy line, and there's half circles, that's called a warm front. And it's the opposite of a cold front. It's a warm air mass. Okay. Occluded front. Occluded, or hidden, occluded means like hidden. It's when you have interchanging triangle, circle, triangle, half circle. So whenever you see that, that's called an occluded front. And this is when warm air is pushed up by cold air. Alright. Stationary. If something is stationary, it means it doesn't move. A stationary front is triangles and circles, but they're on opposite sides. So triangle on the top, half sun on the bottom, triangle on the top, half circle or sun thingy on the bottom. Okay, remember, stationary means it doesn't move. So this is when cold air and warm air push each other, but they don't move. Push each other. And if you look at the lines, it kind of makes sense. This is cold air, warm air. They're like, you know, pushing each other, but they, cold air, warm air, push each other, but they don't move. Okay? So stationary means they don't move. Okay, so you have a mountain. Okay, as you go up, you increase in elevation. Okay, it gets higher, or altitude. So, where is there more air pressure? At the top of the mountain or on the bottom? So you need to know air pressure on the bottom, and if you want, you can do this. Draw a lot of circles really close to each other. So if you're closer to the ground, you have lots of air pressure. When you go up, as altitude increases, what's the air pressure like here at the top of the mountain? Air pressure decreases. There's not that much air. So draw a bunch of circles, but space them out. Okay? So, where do you have more air pressure? At the bottom of the mountain or at the top? Of course, on the bottom. So you need to know that as altitude increases, air pressure decreases. And we drew that. Here there's air pressure really close together, and as you increase in altitude, air pressure becomes less. As altitude increases, so as you go up in elevation, air density decreases as well. The molecules get less dense. They're more spaced out. Density, remember, is how tightly packed something is. As altitude increases, temperature, over here, let's say it's like 28 degrees Celsius. If you go up this mountain, what's going to happen to the temperature? Is it going to get hotter or colder? it'll get colder. So if you go up in altitude, temperature will also decrease as well. Okay, what is the difference between weather and climate? Weather is daily. So on Monday it's raining, on Tuesday it's partly cloudy, on Wednesday it's snowing. So weather is day-to-day changes in our atmosphere. Okay? Climate, on the other hand, climate is long-term. So climate is weather over a long period of time. Okay? So, for example, if I asked you, what is the climate of a desert? Over time, a desert is mostly hot and dry. So we say the desert has a hot and dry climate. But maybe on Monday morning in the desert, the weather was rainy. Maybe it rained that day in the desert. But overall, over a long period of time, the climate of the desert is hot and dry. Okay? Alright, you have a bunch of different clouds over here. Kind of hard to see. Cumulus, cirrus, cumulonimbus, stratus. Alright? So describe each cloud type. Cirrus. These are high clouds and they're feather-like. Alright? So here are cirrus clouds, high and feather-like. Cumulus. These are those low, fat, puffy ones. And they usually mean a good sunny day. So I'm going to write nice weather. Okay? These are these nice, big, cumulus, puffy clouds. Stratus are flat and low clouds. Okay? If you look over here, these are your stratus clouds. They're flat and they're low compared to cirrus, which are usually higher. Nimbostratus. Anytime you see the word nimbo, you need to think storm or stormy. Okay? So, nimbostratus, these are low, large storm clouds. Okay? Do we have nimbostratus here? Got altostratus. So we'll call these low, large. Oops, my light's turned off. Let me fix that. So I guess these would be most likely be nimbostratus because they're low clouds and they're large and it's also storming right here. Alright? And then the last one are cumulonimbus. These are high, large storm clouds. Okay? I know they're storm clouds because I see this nimbus word on there. And we already know cumulo means large, fat, and puffy. So if you look up, these are cumulonimbus clouds. They're large and they're high up and they're storm clouds. So these are cumulonimbus clouds. And these are nimbostratus clouds. Alright? Just make sure you know your weathers. So this is sad weather, or bad weather. Okay. What exactly is the weather? Humidity is moisture in the air. Okay? So how wet the air is. So if you say, oh, it's a humid day, that means the air feels like very sticky, very warm, it's like suffocating. Okay? we measure we measure humidity with a tool called a hygrometer. A hygrometer. Temperature is the average kinetic energy in the air. It measures how hot or cold the air is. Okay? And we know, hopefully by now, we use a thermometer to measure air temperature. It's the average kinetic energy in the air. So I could say the average kinetic energy in the air today is 32 degrees Celsius. It's kind of a hot day. Okay. Wind is the movement of air. Okay. If we're measuring wind speed, we use a weather tool called an anemometer. Anemometer. Okay, they're like little cups that spin in a circle that measures how many kilometers per hour the wind speed is. If we are measuring wind direction, like is it north, south, east, or west, we use a wind vane. You know those things on farms that have like a little cockatoo on them and they point to the direction of the wind? That's a wind vane. Okay? Precipitation is whatever type of water coming down from the sky. Snow, rain, hail, sleet, those are all different kinds of precipitation. If it's rain, we use a rain gauge to measure how many millimeters of water got in there. So it's just basically a little cup, and it's like, today it rained 2 millimeters or 3 millimeters. That's called a rain gauge. And a cloud cover is just a mass or a group of clouds. Okay, so that was weather and atmosphere and clouds and elevation. Now let's go into more outer space. Okay, draw arrows to represent rotation and revolution. A rotation is the Earth spinning. Okay? One rotation is 24 hours. Okay? So one rotation is 1 day. A revolution is when the Earth spins around the sun. Okay? A revolution is 1 year. Okay? So, the Earth spinning 24 hours, we call this a rotation. And it takes 24 hours. As the Earth rotates, it spins and revolves around the sun. Okay? So it's spinning, it just rotates while it revolves. This is the revolution, and this is 1 year. So 1 year is 1 revolution. 1 spin is 1 rotation, or 1 day. And 1 revolution is 1 year. Alright? Know the difference. Rotation, 24 hours, 1 day. Revolution, around the sun. Okay. Remember, it says label the planets, gas giants and terrestrial. If you don't know the mnemonic, remember, my very excellent mother just served us nachos. Okay? So, it starts with the sun. The sun is not a planet. All of these planets in our solar system revolve around the sun. Okay? The sun is a star. It's not a planet. It's a star. The first planet is Mercury, followed by Venus, followed by Earth, followed by Mars, and then after that we have Jupiter, and then after Jupiter we have Saturn, and then after Saturn, this is pronounced Uranus, and then after Uranus we have Neptune, and then Pluto is a dwarf planet. Doesn't count. Okay, it says label the gas giants and the terrestrial planets. So you should know these right here are gas giants. They're made out of gas and they're giant. Terrestrial. Terre means rocky or made from earth. Okay, so you need to know these planets are the terrestrial planets. In Spanish, it would be like tierra, terrestrial. It's from this, they have soil. Okay. The asteroid belt is, you can just draw it over here, a group of asteroids that separates the terrestrial planets from the gas giants. So let's just write asteroid belt over here. Circle the planets that have at least one moon. Earth. Let's just circle Earth. I think the planet that has the most moons is Jupiter. I think Jupiter has like more than 70 moons. Okay? But yeah, definitely for the SOL, know the order, know which ones are terrestrial, know which ones are gas giants, and the location of the asteroid belt, and the sun is a star. Okay? Okay, name the phases of the moon. Use these words. So, moon phases is something I struggle with. So let's just copy these down. When you can't see the moon, it's all black. We call this new moon. Okay, when you see a little sliver, a little crescent, this is called waxing crescent. Crescent. Okay. And then this is the first quarter moon. And then after waxing, you wax on and you wane off. So this is, wait, waxing, oh, I forgot to give us. Waxing crescent, and then this is when it's mostly illuminated. We call this waxing gibbous. Okay, when it's a beautiful moon, we say, "Oh, look at the full! It's a full moon tonight," right? And then we wax on and we wane off. So waning gibbous. And then this is third quarter. Okay. And then this is waning crescent. Okay. So crescent, this is a crescent. Crescent means like a sliver of a moon. Okay. Gibbous is when you can see most of the moon is illuminated, or is illuminated, meaning lit. Right? Explain how we see a full moon on the Earth. That's because the Earth shines around the Earth onto the moon. Or excuse me, not the Earth, the sun. The sun shines around the Earth onto the moon. Okay? So, what causes tides? That's the whole point of the moon. The moon's gravity causes the tides. Like when it's high tide or low tide, that is caused by the moon's gravity. What causes day and night? Well, one day is a rotation. So a rotation of the Earth causes a day and night. Rotation of the Earth. Alright? So when this Earth rotates or spins once, that's day and night, that's 24 hours. Okay, what two things causes the fourth seasons? Okay, what you need to know is if this is the sun, okay, and the Earth is spinning or revolving around the sun, most people assume that the Earth is like straight up and down and it spins around like this. That is not true. What you need to know that the Earth is actually tilted. So I would draw this. So the Earth is tilted as it revolves around the sun and it spins. So that's what causes the seasons. That's why it's like when it's spring, when it's summertime in Virginia, it's winter time in like Argentina, because their part is on the bottom, the southern hemisphere, and we're on the north. So the first thing that causes seasons are the tilt of the Earth on its axis. Okay, this right here, this tilt, this is the axis. Okay, and the second thing that causes it is as it's tilting, it's revolving around the sun. So wherever position it's at, revolving around the sun, whatever position it's at is what season it is. How long does it take for the Earth to make one revolution around the sun? We said that. A revolution is 1 year. Okay. And this is kind of a perfect segue. Identify the seasons as spring, summer, fall, or winter. So this is what I was talking about. I should have seen this first. The Earth is tilted on its axis. Right? It's not straight up and down. And because of this tilt, depending on where it's revolving, that's what causes the season. So, and this is really, it says, identify the seasons in the northern hemisphere. So where we live, as Earth is around the sun. So if you look over here, the northern hemisphere is this part. Most of this is facing towards the sun. So that means the northern hemisphere is going to be getting a lot of heat. This is summer. Okay? If you look over here, most of the northern hemisphere is pointed away from the sun. It's the complete opposite. So this is going to be winter. Okay? What comes in between summer and winter? When the northern hemisphere is kind of like almost halfway, this is fall. Okay? Or we say autumn, same thing. And then over here, of course, would be spring. So this is what causes the seasons. It's the tilt on the axis, and it's also the revolution around the sun. Okay. Almost there. The water cycle. Label the parts. So you need to know water is constantly being cycled around and around of our ecosystems. So let's start over here. When the sun radiates, so this is called radiation. Well, that's not part of the water cycle. So, the sun is radiating on this puddle of water. When this puddle of water heats up, the water vapor goes from a liquid to a gas. This is called evaporation. Okay? Evaporation. And over here, this water as a gas is called water vapor. Okay? When water vapor is evaporated, it slows down, and as it slows down, it forms a cloud. This is called condensation. Condensation. Condensation is when you can go from this gas to a condensed cloud. When the cloud is full, like when your bladder is full and you have to use the bathroom, you have to use the bathroom. And then water droplets fall in the form of precipitation. Precipitation. Okay? So that's the water cycle. The sun evaporates water, water vapor rises, it condenses into a cloud, and then when the cloud is full, it falls down into precipitation, and then the whole cycle starts over again. So evaporation to condensation to precipitation. Okay, it says renewable or non-renewable. Okay, remember, why do we care? Okay, we care. Let's do this first. Why should we care if it's renewable or non-renewable? You need to know that renewable energy is clean energy. It doesn't kill the earth, and we can never run out of it. Okay. Non-renewable, I'm just going to write non-renew. Okay. Non-renewable, most of the, first of all, we can run out, because that's what non-renewable means. We can run out of it. Okay. And a lot of the times it hurts or pollutes our atmosphere. So it hurts or pollutes our atmosphere. Not all the time, but most of them do. Okay? So, hydroelectric dams, that's when we put, like, when we get electricity from, like, big dams of water. That's renewable. Okay? We're not going to run out of rain. We're not going to run out of the dams to make those water, to make electricity from the water. So that's renewable. Nuclear power, that's when we split an atom's nucleus and it makes a ton of energy for us. Nuclear power is actually non-renewable, because we can run out of the chemicals that we get from the earth to make that sort of energy. And nuclear power, even though it's non-renewable, it doesn't exactly pollute our air because it's clean, but nuclear power can be unsafe, especially when we're trying to dispose of stuff. Okay? Fossil fuel, this is when they burn coal, oil, and natural gas and they cause global warming and kill our atmosphere. This is, of course, non-renewable. Okay, because we're going to run out of gas one day. That's petroleum, coal. Okay, that's not renewable. Solar energy, like those solar panels, that's renewable. We're not going to run out of sun anytime soon, maybe in a couple billion years. Biomass is using, like, trees to make, like, the wood from trees, or anything that was formerly living is called biomass energy. This is renewable. Geothermal energy is energy from the heat inside the Earth's core and crust. This is also renewable. And then wind energy is renewable, because we're not going to run out of wind anytime soon. Alright, so that was 6th grade science. So like I was saying, make sure you know all this about weather, about the atmosphere, about the planets, about what causes the seasons. Moon phases, I know, are tricky, but I would say the most important thing to know about the moon is that they cause our tides, and also know the difference between renewable and non-renewable. Review your cloud types, and yeah, this is all 6th grade science.